Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at mechanics, resolving forces, part 2, resultant. Now in part 1 we looked at resolving forces with equilibrium where all the forces are balanced, or in other words they add up to 0. Here we're going to have a remainder or a leftover that we're going to use to find the resultant force. Or you can call it the net force if you want. So that is what we're going to look at in today. And let's just jump right into the questions. So let's go to the screen so you can read the first question. And it says, coplanar forces of magnitudes 12, 24, and 30 act at a point in the direction shown in the diagram. Again, remember, coplanar just means they're all in the same plane, so this is a flat diagram. Find the components of the resultant of the three forces in the x and in the y direction. Then the second part of the question is, hence, find the direction of the resultant. So let's start with this, and let me get it on the board. Okay, I have our graph on the board. So the first thing that we want to look for, other than whether it's equilibrium or resultant, in this case it clearly said there's a resultant force. So the second thing after that we want to look for is our angles. Remember, we want all of our angles to be oriented to the x-axis. That way we don't get confused in our Sekolah. So this one is just straight up and down, no problem there. This one is already to the x-axis, so no problem there. But this one, we need this angle here to the x-axis. So we know that a straight line adds up to 180. So you want to take 180 minus the 90. There's a 90-degree angle in here. And the 25 on that side. And so when we get this, we can do it really quickly on our calculator. 180 minus the 90 minus the 25 gives us a 65-degree angle. So we have a 65-degree angle in there. Now we have our angles all to the x-axis. So let's start by resolving our individual forces down to horizontal and vertical components. Well, this one is already a vertical component. So we'll have an up arrow, resolving it vertically equals 30, one of those. We have two down arrows. So we have a down arrow that is, if we take this one, 12 sine of 65. And then we have another down arrow of 24 sine of 25 degrees. Okay, so again, we're looking at this little part right here going down, and this little part right here going down. And these are the opposites in our Sekolah, opposite being sine, and the hypotenuse being the 12 and 24. So there's our three vertical components. Now we want our horizontal components. This 30 does not have a horizontal component. So we have one in the right direction being 24 cosine, because it's the adjacent side, cosine of 25 degrees. And we have a left arrow being 12 times cosine of 65 degrees. Now what we want to do, we can subtract them really in any order. You might end up with a negative, but I try to keep it positive. So we want to try to take the bigger minus the smaller. This one here in the diagram looks much higher than those two. So assuming the diagram is relatively proportional, we're going to start with our 30, or we can start actually with our net force. Our net force, and we'll put in the vertical direction equals 30 minus the two down ones, assuming that they're the smaller one. So 12 sine 65, and this negative distributes 24 sine 25. So if we do that on our calculator, then we take 30 minus parentheses 12 sine of 65 plus 24 sine of 25 equals 8.98. So our force in the upwards direction is 8.98 newtons. Then we also want to take care of the left and right. Well, this one looks bigger than this one, so let's find our net force going to the right, which will equal 24 cosine 25 minus this one, 12 cosine of 65, and that will give us a value of 24 cosine 25 minus 12 cosine 65, 16.67. And that is the right direction. So what we've done is we have resolved all of the forces into horizontal and vertical components. Then, because we know that there's a resultant, we know that one side is heavier than the other. So we take the bigger side, either top to bottom or left to right, and then we subtract the smaller side and see what the remainder is. So the bigger vector, and if you don't know, it doesn't matter, just subtract the two sides. If you get a negative, you just know you got it in the wrong direction. So 30 minus the other two gives us 8.98 in the upward direction, and the 24 cosine 25 minus 12 cosine 65 gives us a 16.67 Newton in the right direction. So let's go back again to the question really quick to see what exactly it's asking for. So find the components of these forces in the X and Y direction, and then it wants us to find the direction. Okay, so this one is in the y-axis direction, and this one is in the x-axis direction. So these are our two answers right here. Then it wants us to find the direction of this resultant force. So from our point of reference, just put it down here, from our point of reference, we are going to the right and up. We are going 16.67 to the right, and we are going 8.98 up. And what we want to find is this angle right in there. So theta, or tan theta, opposite over adjacent, or SOHCAHTOA, equals 8.98 over 16.67. And then, of course, our theta is going to be the inverse tangent of that. And that is going to equal, let's see what we have here, inverse tangent, inverse tangent, 8.98 divided by 16.67, and we have 28.3 degrees. And that is our answer. Remember, when it's talking about direction, vectors have magnitude and direction. So if it asks for magnitude, that would be the Pythagorean theorem, a squared plus b squared equals c squared. If it's talking about direction, it's referring to rotating from 0 degrees or from your nearest x-axis. So we would say 28.3 degrees. And actually, if you wanted to give it a little bit more detail, you would say up or counterclockwise from the positive x-axis. So that's what I would say. I would say 28.3 degrees up or counterclockwise, up is just shorter word, from the positive x-axis. So that's the direction, okay? So let me set up the next problem for us. Okay, let's look at our second problem. So we'll go to our screen here. It says coplanar forces of magnitudes 15 newtons, 25 newtons, and 30 newtons act at a point B on the line ABC in the direction shown in the diagram. Find the magnitude and direction of the resultant force. So notice this is 6 points. Find magnitude and direction of the resultant force. Then in the second part, it says the force of magnitude 15 is replaced with this unknown magnitude force acting in the same direction, and that the new resultant has a 0 component in the direction of BC. Find the value of F and also find the magnitude and direction of the new resultant force. So let's go back to our screen and get ready to start this problem here. Okay, we're going to start by resolving our forces. So again, like we've done before, we'll resolve vertically. So we have an up force here of 25 sine, because we're looking at this one right here, so sine 30, 25 sine 30. And we have an up force over here with 15 sine 40 degrees. And we have a down force of 30 straight down. Then we have a right force of 15 cosine 40. And we have a left force of 25 cosine 30. So that's this one here and that one there. So now we've resolved the forces both horizontally and vertically. Now we need to figure out the resultant or the remainder of when they're put together. So let's do the up forces here. Not sure which one is going to be bigger. Like I said, it doesn't really matter. So we want our net force going, we'll just say up. We'll figure out if it's up or down. We'll take the 30 minus these here. And 40. So we took our 30, our down force, and subtracting the 2 up forces, and we'll figure out which one is the larger one here in a second. So when we do that, 30 minus 25 sine of 30 plus 15 sine of 40 gives us 7.86, 7.858. 7.858. So that is the up force. Since it was positive, we know that the bigger force is sorry, actually going down. I put the 30 first. So this is the net force in the down direction because I figured the 30 is bigger than these other two, and it is by a little bit. So it's going down at 7.858 newtons. Now we want to compare the left and the right. And I think the left one is bigger. It's got heavier newton and a smaller angle. So our net force to the left would be this one here. Where's our left? 25 cosine 30 minus our 15 cosine 40. Okay. And we want to calculate that out. So 25 cosine 30 minus 15 cosine 40, and it's 10.16. 10.16 newtons in the left direction. So now that we have that, what we want to do is we need to find the magnitude and the direction of our resultant force. So if we make a little triangle out of it, the triangle is going left and down. So the left part is 10.16, and the down part is 7.858. So the magnitude here is just so we have magnitude and our direction. So our magnitude is just the Pythagorean theorem. So magnitude equals the square root of 10.16 squared plus 7.858 squared, the square root of all that. So our magnitude is equal to square root 10.16 squared plus 7.858 squared equals 12.84. And the direction is going to be the inverse tangent of opposite over adjacent. So the inverse tangent, and that's going to give us an angle of inverse tangent 7.858 over 10.16, 37.7 degrees. Now, the way that we want to say this magnitude is coming off like this at 37.7 degrees with 12.8 for a 12.8 Newton force. So we can say 12.8 newtons at 37.7 degrees below the negative x-axis. So that's how I would state it there. 12.8 degrees or 12.8 newtons, that's the magnitude, in the direction or at 37.7 degrees below the negative x-axis. Okay, so that's magnitude and direction. That was the first part of the question. Now we get to the second part of the question where it says to replace the 15 newtons with an F newtons, an unknown newton. So here we have F newtons in the same direction. And it says our resultant now is 0 in the BC direction, meaning horizontally. Okay, so let me get rid of some of this work here so that we have a little space to work with. Okay, so it said to replace the 15 with F. It wants us to find, of course, the value of F and the new magnitude and direction of our new resultant force. So let's look and see what we can keep from our previous work. As far as the 25 goes, that is still the same for the up and the left. As far as the 15, we're going to replace that now with our F. And that means this one also here is now an F. And the 30 is still the same. So all we had to do is swap out the 15 for F. And now the key here is that the horizontal forces are now balanced or equal 0. So our force F cosine 40 has to equal our 25 cosine 30. So if we solve for F, F equals 25 cosine 30 divided by cosine of 40 degrees. And when we do that on our calculator, 25 cosine 30 divided by cosine of 40 equals 28.26. So 28.26 newtons. Get more clear. And so I'll go ahead and put up here F equals 28.3 newtons, so 3 significant figures, so we already have that answer there. But we want to use 4 significant figures here. So now that we have that, now we have a value to put in here. So let's go ahead and put that in. Let's do the vertical part. So if we do the vertical part, we have our net force, we'll say going down again. We'll assume the 30 is bigger, it might not be. So the 30 minus our 25 sine 30 combined with our F, which is 28.26 times sine of 40. Okay, so you choose a direction. Like I said, it doesn't really matter. I'll just make the 30 first. It's the one going down minus the sum of the two ones going up. They're going in the same direction, so they added together. We plugged in our F value into it. So let's see what we get when we do that. 30 minus 25 sine 30 degrees plus 28.26 sine of 40 degrees. And what we get from that is a negative 0.665, negative 0.665. And basically what that means is we're going the wrong direction. So it's actually our net force going up. This is actually an up in this here 0.665. And when I look at here, I have 0.667 on my paper, so somewhere I lost a decimal. 0.667 maybe I should have taken F to one more point value because that's the only place where I can see where it was rounded. So my third significant figure here is a little off. And you have to watch that. When you look in the mark scheme and you see that your answer was off by just a little bit, don't just let it go. You need to go back and look at why that is. So maybe I rounded this one here. When we got this, we come back here and try that again. 25 cosine of 30 divided by cosine of 40 equals 28.26, basically 3. If we go another one here. And so if I add that 3 in there, let's see if that helps. 30 minus 25. Because if you don't fix it, you will lose a point in Cambridge. They're quite picky on the significant figures, and it helps you be more accurate as well. 28.263 sine of 40. And when we do that, yes, we get negative 0.667. So usually if you go to 4 significant figures in your work, your final answer should be accurate to 3 significant figures. For some reason, we needed that 5th significant figure. I'm not quite sure why, to get our 0.667 in the up direction. So it's asking for F. We found F over here, already have that. And it's found our magnitude and direction for our new resultant. Well, this is the new resultant. It's 0.667 upwards, or you could say 90 degrees up, from your x-axis, positive x-axis, you could say that, but 0.667 upwards is fine. That is the magnitude and direction being straight up of the new resultant force. Notice it just makes a little tiny resultant force, the new one, when you replace that or you make that bigger. It went from 15 up to 28.3, and it made the left and right even. It also increased, because this force increased, it also increased the y value, which ended up, sorry, that's not even going up, it's going down, but just a little bit, going down just a little bit there for our final resultant force. Okay, so I think we got one more to look at. Let me set that one up. Okay, here's our last question for this section. Let's look at it from the past paper. You can see, by the way, I haven't really mentioned it, but if you look at the top of the picture here, you can find out where it's from. This is from the Winter 19, which would be the October-November series. Winter 19, paper 43. So this is paper 4, meaning mechanics, zone 3, and then number 3 on that past paper. So when I show these, you can figure out where I'm getting them from, but it's just a selection from a past paper. So here we have our diagram. It says 3 coplanar forces of magnitude 50, 60, and 100 act on a point. The resultant of the forces has the magnitude Rn. So this dotted line here is the resultant force. The direction of these forces are shown in the diagram. So in other words, we have this one straight out 20 degrees. This one's 30 degrees off the y-axis, and this one's alpha degrees off the y-axis. Find the values of R and alpha. So we're still finding the magnitude and direction of the resultant force. So let's go back to the board. I've drawn it on the board. So again, first thing you want to establish with these resolving forces questions is whether you're dealing with equilibrium or resultant. This one, clearly we're working with the resultant. They even drew in the picture. Then the second thing is making sure your orientation with the x-axis. So I'm going to take this 30 degrees here and come on this side and make it 60 degrees. So that way we're with the x-axis. And this alpha over here is going to be 90 minus alpha. Okay, so 90 minus alpha for this one here. So let's get started. Let's resolve our forces. If we do the up forces, we have an up force of 50 sine 20. That's this one right here. And then we have a down force. So we change to the 60 so that we're with the x-axis. We have a down force of 100 sine 60, sine of 60. Then for our left forces, we have a 60. We have another left force of 50 cosine 20. And we have a right force of 100 cosine 60. Okay, so 100 cosine, that one, 60 for that. Okay, now we want to find the resultant. Well, at least with the picture, we can tell which direction we're going, so that we know that these forces are resolved downward. So our net force going downwards is going to be this one here, 100 sine 60, minus this one here, 50 sine 20, and it's going to be in the downward direction. So when we do that on the calculator here, 100 sine 60 minus 50 sine 20 gives us 69.5. So we get 69.5. And then we want to do the left and right. So obviously it's coming to the right. Sorry, to the left, not to the right. Coming to the left. So that's the 60 plus the 50 cosine 20 minus the 100 cosine 60. So this gives us a left of 60 plus 50 cosine 20 minus the 100 cosine 60. That equals 56.98. 56.98. So now to find magnitude and direction, we went over and down. We went over 56.98, down 69.5, and we want to find this magnitude and the direction, which we'll have to convert to alpha. So the hypotenuse or the magnitude is the square root of 56.98 squared plus 69.5 squared. And that's going to equal square root of 56.98 squared plus 69.5 squared equals 89.87. 89.87. And then the theta is the inverse tangent of 69.5 over 56.98. So that gives us a theta of inverse tangent 69.5 over 56.98. 50.65. So our force, we have to find alpha. Alpha is 90 minus, so this is 50.65. 50.65. And we want to basically subtract that from 90. 90 minus that, 39.34. So our magnitude and direction is a magnitude of 89.9 newtons at 39.34 degrees from the negative y-axis. And actually, it just asked us to find the magnitude and the direction. So our R is this one, and our alpha is that one. So you can just put that for our answer, okay? So again, pay close attention to which axis you are oriented to, okay? So I hope now that we've covered resolving forces, equilibrium, and now part 2, resultant, that you're able to either break apart or combine forces with your trigonometry and your axes so that you can be successful at the skill which you're going to apply in future question types. So again, thank you for joining me, and see you again next time in the Zoom room.